So hello everyone. Today we're going to talk about why we were in a pickle a little while ago. But first, before we do that, let's give ourselves a little bit of an introduction. Go to the. Oh, yeah, the slides too. So who are we? Well, we're from Eneco. We're both data scientists. So my name is Corné Vriends, and as we just discussed, I've studied econometrics here. But I've mainly been working on the Toon and the smart thermostat. And that's something that's very interesting, but we'll talk about that in a little while. Let's first introduce Rick himself.
I'm Rick. I'm a data scientist. I do a lot of data science, but I also like being involved with the data engineering. And as you might know, with data engineering comes a lot of interesting challenges. And in a sense, I like those challenges as much as the actual data science work, because, I don't know, if there's an interesting problem, I'm always in for it, trying to solve it. So that's what we are going to talk to you about today. So let me start with a story. The story starts on a Friday afternoon. We thought, oh, we have our nice cloud environment where we run our jobs. Hey, there's a new version, and it has like some performance improvements, some other nice improvements. Let's make a small merge request, and we'll just update the version for the jobs. What could possibly go wrong? Actually, it didn't really happen on Friday afternoon, but just for dramatic purposes, of course. This happened. We got a very large error. We didn't know what was happening, and it was also the beginning of a long story. For us, it was a very long story. For you, it will be about half an hour. The only hint that we got at the beginning was an integer is required, got type bytes, and it has to do something with pickling. So that's a little bit of a teaser, but we'll tell you in this talk how the way we store our machine learning models suddenly became incompatible overnight, and how we kind of had to rethink some of our steps and what we did in the end. It's also a little bit open-ended, but we also have some insights that we want to share with you. Yep. So first, Corné will talk a little bit about a bit of the broader context, I will guess.
Yeah. So before we dive into the technical details, let's talk about the Toon. So the Toon is a smart thermostat from Eneco, and it's special in that sense that you connect it to your smart meter. And your smart meter has two types of resolution data. So it has high resolution, that's on change or on second or 1 second interval data. And the low resolution data, if you've been to the talk this morning from Rick and Fenno earlier, you've seen a talk about the low resolution data and what we do with that. But today we're going to mainly talk about the data services that we deliver with the high resolution data. So the Toon is a smart thermostat, but it gives you a lot more information. So one of the things is, for example, the waste checker. I'll tell you a little bit more about that in a second. We have the bill breakdown. That's a disaggregation of your energy bill into different appliances. We have the away check. So we try to give you advice on whether your heating is on while you aren't home. We have monthly energy insights. So we give you an energy booklet or a digital booklet that states something about sustainability of your home and your behavior. We have boiler monitoring. So we try to monitor your boiler and see whether your pressure, for example, is varying over time or not. And we have simple solar monitoring. So is your solar system up to par with the rest of what it should be? So that's what the Toon mainly does. If we go to the next slide, I'll explain something about the waste checker. So as you read in the leaflet, you've seen that we're going to talk about machine learning at scale, right? So before we talk about scale, let's discuss a little bit of the waste checker use case. So with the waste checker use case, we try to identify whether your appliances and appliances that you use, whether they are used in a wasteful manner or not. So, for example, is your dishwasher on a too high temperature? Is your washing machine not on the eco mode? And we try to give you a hint on whether you should use it differently or not. But what's the skill in this picture? So if you go to the next one. So if we talk about skill, we have around 200,000 to 300,000 customers that use the Toon. And every day we detect around 75,000 dishwasher cycles. And if you do the math, that's perfectly on here. You see that that's roughly 13 years of dishwashers running end-to-end, so continuously. And over a quarter of them are not used efficiently. So if we can detect those and say like, hey, come on, use it perhaps a little bit more efficient, so put on the eco mode or wash it on a lower temperature, then we can really move the needle forward on helping people be more sustainable at home. But that is just one use case. Let's talk a little bit about our general setup that we have at our team. So this is a simple slide that shows our architecture. So our IoT stream, if you click the next one. Our IoT stream is around 1 terabyte per day that we get of smart meter data, so that's quite a lot. And especially the IoT stream and the click data blocks, those are separate from all the other ones. The other ones are connected through a platform it's a platform, but it's called Databricks. And Databricks is mainly a supplier for Apache Spark at a corporate level. So our batch processing is in Databricks, our notebooks are in Databricks, our real-time services are in Databricks, and also our dashboard. And that's important for later on why we're trying to move a DBR version higher. And we use MLflow and MLflow registry. And also in the talk this morning, if you were there, we talked a little bit about how we use MLflow and the MLflow registry there. But if you click on the next one, we have in the Delta Lake around 1 petabyte of data, so that's quite a lot. So that's also why we have to use Spark to make it all happen. And MLflow, around 500 models are logged, and those are also experiments, but also experiments that we use in production. And in MLflow registry, we have around 8 deployments that we actively track, so 8 models that are actively in production. And besides the models that we track, there are also a lot of unsupervised models. So if you click next. We have around 1 million unsupervised models that we train, and that's mainly made up out of the bill breakdown that I talked earlier about. We have several appliances there, and for each user and each appliance, we train an unsupervised model on the fly, so that's how you get to the 1 million number, if you ever want to know where that comes from. So I think the next one is for you.
Yes, so this is a picture that might look familiar, but I will go over it a little bit. So basically, our flow exists of 2 things. At the bottom, we have all the experimentation that we do to make a model. The top part is about using a model, right? So there's one flow when you want to use a model. Every day you want to have some batch pipeline that for everybody detects the appliances or judges their efficiency or inefficiency or anything of that matter. And at the bottom is your ML flow where you have like a notebook or any environment that you want to train a model. But the important part, and I guess the focus of this talk today is in the middle part. So how do you go from your model that you have live, that you want to preserve, to something that you finally use in prediction? And a very common method to do this is called pickling. That's why there's also a picture of pickles there. And I think, I didn't look this up, but I think the reason is this. If you have, basically pickling is also this, right? You take some fresh cucumber, some fresh vegetable, and then you put it in a pickle solution to preserve it, so you can use it at a later time. So pickles, or augurken in Dutch, are a way of preserving food, but they're also a way of preserving models. And as a matter of fact, there's also an English idiom, which means I'm in a pickle. That means you're in a bad situation. And, well, there's a little bit of truth in all of those 3 explanations today. So basically what happens when you do pickle, you just have your model, you fit it. There's a very minimal machine learning example. And then, in our case, we use the MLflow library. That's just a wrapper that under the hood calls some like maybe joblib or cloud pickle or the other pickle library. There's a number of libraries that can do this conversion from a Python object, can be any object, in our case a machine learning object, including the state of that object, and maybe some other functions that you wrote can also be included in the pickle. And you just take whatever object is in memory, in your Python memory, and you just convert it to a bunch of zeros and ones. And in our case, we also log a number of other things. So we have like a conda YAML. We have a requirements text to kind of like specify what was the environment when we were training. So what Python version would you use? What library versions did we use? But the important part, like the real pickle, that's the model.pickle that you see here. So that's the bottom part, right? You make a model, and then you convert it to binary, and then later you can convert that binary back to a Python object, and that is an object where you can call predict, or you can load it into Spark and do your predictions there, whatever you like. But here comes the painful part. Because you're basically just converting everything that you have to binary data in that specific Python environment, if you're converting it back, it must be compatible to whatever you had. Otherwise, it's a little bit like you have your Roller Coaster Tycoon CD, and you put it in your new MacBook, and it says, I cannot read this. I have a completely different environment. So you need to have the same versions. And in our case, when we switched our environments from some environment on Python 3.7, and we tried to load it back on 3.8, we got this weird error says, I expected this type. Error could have been better, but it basically meant I cannot read what you wrote back then anymore. So that's a little bit to go back to our flow, because we use Spark in a distributed way to make our predictions. So basically what we do here, we have Spark, we have some Scala, we have some Python code, all in Spark. And we can use Spark as a distributed engine. So you can have any number of workers, and they all read a little bit of the data, and then do the prediction of there. And it's really nice because it can scale easily to, well, the sizes that Corné just showed on the other slide. But the thing is, because we have this pickle in the middle, we kind of have a locked-in dependency between the Python version of our Spark and the Python version that we originally trained there. And that's kind of the hard realization we came to, that either you kind of like need to stick to the same Python version everywhere, or, okay, I'll get to that in a second. So we run on a platform called Databricks. Basically everything we do there, and they manage an environment for us, which is called Databricks Runtime, and it comes with a bunch of Spark versions, but also some machine learning library versions. And it's really nice for us because we don't have to worry that much about keeping track of all the versions, and we have kind of like one unified version. But the thing is, they release a lot of new updates, usually exciting updates with new features, maybe performance improvement for Spark. And that makes us want to upgrade. But in some cases, the upgrades can be breaking, as we just saw before. And this is just a bit of a timeline of like when the release versions were upgraded. So actually, I think it was the beginning of this year when we first thought like, okay, let's see if we can do this update. And by the time we were done, we were thinking, okay, maybe like not migrate to 8.4, but let's go to the next version already, because there's also a long-term support version now. So basically, our problem was we have kind of this locked-in issue with the model that we have trained, which is pickled, and we want to load it, but it always needs to be the same version. So in a really basic way, what can we do about it? Well, either we need to move away from using this pickle and find some other way to preserve our models or vegetables or whatever, or we need to find some way to keep using the old version that the model was trained on, just so our predictions job will just be in like a separate container, and it will always have that same old version that we once started with. Or we need to just do it again and make a new pickle. And basically, those are the three a little bit fundamental ways we saw around this problem. And Corné will go more in depth about what it means and how you could implement some of those.
Yeah, so as Rick just explained, there were three fundamental ways how we saw that we could solve the problem. And one was the portable format, one was the containerization option, and the other one was periodically retraining, also for the environment, not just for the data. And the portable format, it's ONNX. I've heard someone already talked about it, but ONNX is a portable format in the sense that you can define a model in a more generic format than what you've had. And you can take it to another hardware platform. For example, you can take it to a Raspberry Pi, you can take it to your smartphone, and you can do inference from there. And also, it can be quite agnostic to software versions that are in there. So that's quite useful. You can just define it in that format, and then just take it from A to B to C to D to E if you want to. Containerization, we mainly looked at MLflow projects, and why is because we're already on the Databricks stack, so if we're going to think about a containerization solution, it has to work seamlessly with our Databricks ecosystem because that's easier to integrate, otherwise it would be quite hard. And then the retraining, that's something that I will talk about a little bit later, but if you move to the next one.
Yes, and as a side note, this is just things we consider as options, but maybe there's like Pummel, there's other portable formats, you can use Docker, Airflow. It's just examples of the kind of solutions, but not a specific preference for those.
Yeah. So yeah, let's go to the portable format that we discussed, ONNX. Well, there are a few benefits and a few drawbacks to why you would go for such a solution. So one thing that's a benefit and a drawback at the same time is that in our use case, we have a lot of pipelines or scikit-learn pipelines, but we've defined them with custom transformations. And those custom transformations are really necessary for all the signal processing that we do. So you have to disentangle the model from the pipeline, and that's something that it requires a lot of work for us to make it happen. But at the same time, it can be a benefit because you have your model separately defined somewhere else, and your pipeline, you just got it in Spark for us, for example. It's environment agnostic, something that I just mentioned. And for some models, it has faster inference than when you just try to load the pickle, load the native libraries, and just do inference there. It has support for a wide variety of models, and it hasn't. So it has support for LightGBM, it has support for PyTorch TensorFlow because it originated from a format for neural networks. And it's also backed by industry giants. So it's backed by Microsoft and by the Linux Foundation. But in our case, we have to revamp a lot of the models that are there. Although there's a wide variety of models that are supported, it is quite limited. So for example, if we have some esoteric model that we want to add into ONNX, that would be quite difficult to do. And it's dependent on development of ONNX runtime, because you define the format in ONNX, and then you have to run it somewhere, and you use ONNX runtime for that. And moreover, one of the reasons why separating the pipeline and the model is quite difficult is that if you want to integrate the pipeline into ONNX, you have to define all the custom transformations in the mathematical syntax of ONNX. So that's, in our case, quite difficult to do, but it would be something that we could do. I'm not going to spoiler the solution or the thing that we chose until the end, of course. So if you go to the next one. So containerization. Well, I think a lot of people know what containerization is, but let's go to the benefits and the drawbacks. It has benefits in the sense that the models and environments are stable. So you can just have your container, you can load your model in there, and you can define all the dependencies that you have there, just keep them up at the same version throughout. The benefit of MLflow project is it's tied into the Databricks ecosystem, so you can just incorporate it in MLflow. And MLflow is mainly the ML registry that we use for registering our models, seeing which one are in production, which one are in staging. It's agnostic to the DBR version, so you can just containerize it, and you can change the DBR version in the rest of your stack to whatever version you'd like to. But in our case, if you don't keep it up to date, if you don't keep the dependencies in the container up to date, it will likely be outdated over time. And that's something that you have to be willing to accept if you want that. Or you have to update it each time, and then there's not really a difference between this one and the last option. And in our case, it's useful that we could incorporate external jars or X, and that's something that's not possible in MLflow projects at this moment. It also would require a disentanglement of the pipeline and the model. So, as I explained in the earlier version with ONNX, we would have to do a good revamp of the models that we have. And we have to change how we do inference right now, because you have to serve the inference from the container. And that's something that's not done in our pipelines right now, so we would really have to revamp that. So in our scenario, this would also entail quite some manual work. So perhaps this one isn't the right option, but we'll see. So the last one, periodically retraining. So if you go to the next one. So periodically retraining. So we retrain every now and then for the new data that comes in. So that's obviously something that's very useful. But something that we also considered, why don't we just retrain on the latest environment? there are some good reasons why you shouldn't, or why you perhaps wouldn't. Because if there are any changes or breaking changes in the dependencies that you have, then your model will also break. But in our case, how we've set up working within the team that we have, it's easier to embed it in our current processes so that we just, for example, periodically retrain it each a quarter or each half year. And then if anything comes up, fix it at that moment, because that's easier manageable than doing it at big leaps every half year or every year in that sense. In our case, if we just pipelinify it as we already have all the other pipelines, it can be more extensively monitored, and also it can be embedded in the rest of our CI/CD. So that's also something that's quite neat. But it has some drawbacks. You have to do retraining perhaps more often than you would like to. So you have to consider the factor of compute, or the cost of compute. And even if you add more models to your model stack, if you retrain them more often than you would like to, then of course the same argument holds. The cost of computation will still be higher. And if you embed it in a maintenance fashion, so as we would like to, so just pipelinify it, then also the maintenance work that we have will be a little bit more than usual. But that's something that I think for us was a good solution. Go to the next one.
Ta-da.
So who won? Who won? Well, in the end, I think during the solutions that I discussed, it was a little bit obvious that this one was going to win in the end. Although this is pretty specific within our constraints. So for us, this is a really good use case to do this. But for other people, the portable format could be a really good solution, or containerization could be really, really well, or something that works really well. But for us, given the size of our team, given how we've already structured our current efforts, so how we pipelinified almost everything, this is something that we've considered to be the best option forward, because we can keep it all up to date, we can make use of the latest features, and we can also retrain it for the data and for the environment at a periodic manner. So what are our main takeaways besides the choice? Well, Pickling models, if you do that, it locks you into your Python and library version. And that's something that, should you be willing to do that? We're not so sure that we want that. Portable formats are very useful, but it's hard to implement in our case because we had so many custom transformations. Containerization can be useful, but as I mentioned, it's hard to separate it out for us. But if you have a separated setup, and if you're going to start off, this is perhaps a good option for you if you want to. And retraining, as I said, it makes it easier for us to keep our models up to date, and also to keep our data and the models up to date. So these were our key takeaways, and this was our struggle with Pickling.
Thanks.
Are there
Any questions?
Yeah.
Where's
the cube?
the box?
Yeah.
Do you want to throw?
Oh. The other vraag? Or really question? Yeah.
Hey, nice presentation. Just a quick question. So right now it sounds like you're retraining the model whenever you're upgrading Python versions or other library versions. Do you ever have a need to reuse old models at some future point in time, for example, to do like a comparison between how the old model was performing and how the new model is performing, and how are you doing that?
Yeah, so that's something that we have to do. So every time if we train a new version or a new iteration of the model, we really look at how does it compare to the other models that we have. And the main thing that we use for that is MLflow. So MLflow and MLflow registry is where we really keep track of all experiments, and also if we do any retraining, how well does it compare to the other models that we have. So if you retrain, better make sure that your model is better than the previous one, or at least up to par with the last one. So good question, but that's something that we do. Yeah.
Cool, thank you.
Oh, sure, try to do.
I have a bit of different question. So use Databricks notebooks, or you are actually developing IDEs?
Sorry?
Do you use Databricks notebooks in production?
Yeah.
Why do you choose for using Databricks notebooks in production instead of?
I can elaborate a little bit on this as well. So what we use the notebooks for is mainly for experimentation. And the nice thing is that they are on the platform, so we can also directly access the data, and you don't have to export any data. Usually we try to keep it as much to only the model itself as possible. So any of the other Spark jobs that we write around it, or some of the transformations that we do, for example, I know, resampling electricity data or something, that we try to write in separate code in our code base. So we have most of the code we develop is like in our code base, and there we can write unit tests, integration tests, whatever we like, both for Scala code and Python code. Then we put that in a jar and an egg, which you also saw happening during the presentation. But the machine learning for us, it's easier to do in a notebook because it just feels more natural to be closer to the data and to have some interaction as well. We're not at this stage yet. For some of the models, we tried also putting some of the feature engineering into unit-tested jobs, but I find it is a bit of a... there's a bit of a tension there, I feel.
Yeah, there is.
Because if you put something in a nice job and you write all the unit tests and integration tests, then if you want to add a feature afterwards, it's going to be a lot more work. So unfortunately, we have some good bookkeeping to still keep track of the models and their performance. But I think normally in like software engineering, you can do test-driven development, right? You say, I want this and this and this outcome, and then I write my software. And I feel in data science is the other way around, where you just go from the data, you experiment, and then you kind of learn what you want. So I think there's an interesting tension between how do you do good software engineering and good data science at the same time.
Yeah, I think it is a hard thing, especially if you use Databricks. We have the same problem. We are trying to find a way actually not to use notebooks. And it is challenging, it is not easy. The main reason with how to incorporate it in CI/CD pipelines is model retraining. You just trigger notebooks, or what do you do?
Sorry?
So
Yes.
the model, you trigger notebooks.
So currently, the models are not in the CI/CD pipeline yet, and that's also one of our pain points. So we definitely also experience pain points there.
Yeah, so for that it's easier to use Python scripts. Then you would have to translate your notebooks into Python scripts and use Databricks job APIs, I guess. That's what
Yes.
we are aiming
Yes.
for.
Well, we can chat a little bit later.
Yeah, that would be nice.
Would be interesting to exchange some thoughts.
Oh, if the mic is on.
Well, I'm not going to throw so far.
Vincent?
I have a mic.
That was a close
it's
call.
broken. Okay. Meanwhile, so you touched very briefly on the topic of retraining a model and when should you do that. And I can definitely agree, like, you don't want to do it every hour because that's a whole lot of compute. But at the same time, gas prices suddenly rise up. So there's something to be said that on the short term, there might be something happening that's causing a lot of different behavior. So that makes me wonder, especially in your market, I could imagine that you might want to be able to trigger off retrainings manually, but I can also imagine that you might want to schedule this on a regular basis. Do you have any insights on that? Because it seems like a relevant topic, no?
Yeah, it's an interesting question. It's also something we've been thinking about because it really depends on the use case as well, I think.
Yep.
So for some of the use cases, also about the amount of training data that you have available, right? If you only have a fixed training set, there's not that much use, I think, in running it again every night, right? But especially, well, example, the solar model, I was also talking about this morning. I think there, if you have continuous data available, then it also makes sense to continuously retrain. I don't know. We have a lot of future visions about this also. I think it would be nice to, if you do the inference, to also infer on like a sample data set, and then you can maybe track if there's any drift and use it in that way. But we don't have that yet. So, yes, in the back.
So we talked a lot of research that I can use myself. I was interested, how do you guys manage the workload of people who manage the models? Because if you're going to upgrade a low-level thing like a Python library or a Python version number, all the models break all at once. And then because your production environment has a very specific version. How do you make sure that they don't overload a group of people with a lot of work to fix these models?
So your question is, how do we manage all those dependencies everywhere if something changes? Or
Okay, so if you had one production environment with one particular version of Python,
yes,
and you upgraded that version,
yes,
all the models that would break with the new version broke all at once, because you would run the models every day, presumably. How do you manage the workload on the people who have to fix these models? Because now they have a lot of models to fix all at once.
well, yeah. So first of all, of course, first we have an acceptance environment, so we can spot it in advance, then roll back, and just take it easy before all panics breaks loose. But indeed, that's kind of the pain that we've been having, right? Yeah. So it was also a good lesson in going back over some of the models to see, hey, I made something, and even though I have all the nice versioning tools, how easy is it really to reconstruct a training data set, and how can I structure that in a better way? So I think it's not easy, but it was a lesson for us, like in how can we set it up in a better way, so it's also more reproducible and less man hours to redo some things.
Yeah. And I also think if they all break at the same time, it's quite likely that's the same cause. And then it's just a matter of trying to find what's the actual problem that caused it, and then you only have to fix it once instead of for every model. So it's also quite dependent on what breaks and what causes it to break. If it's like different causes for each model, it's going to be a huge workload. But if it's only one cause for all models, then it's better manageable.
So if I can ask the last question, which is related. So if you would have had many different models from different teams, would you choose the containerized option then?
That's a good one.
Okay, maybe it's something for the break, because we have 5 minutes to switch for anybody who wants. So let's give a big applause.